All right, we're doing page number 3 now. That's questions 4, 5, and 6. So the very first question, number 4, I have not taught this to you yet, but this is a real classic question in Algebra 2. So Susan won $2,000, invested it, interest rate of 3.2%, so we're going to be earning money. Her investment were compounded monthly. That is how we transform this question from Algebra 1, which I taught you the formula, principal 1 plus the rate to the amount of time. That was in 9th grade or Algebra 1. In Algebra 2, we start talking about this compounding period. So what we would do is we would take this rate and we would give it out monthly. Well, there's 12 months in a year. But if this is monthly, this has to be monthly as well. The deal is that these numbers have to be similar. Okay, so you can't have months and years. You have to have months and months, or years and years. They have to be the same. So this is how that formula changes from Algebra 1 to Algebra 2. So I'm going to start out using basic Algebra 1 ideas. She started with $2,000. That goes here. All right. 1, we're taking 100% of that money and we are increasing it by 3.2%. We have to move that decimal 2 places to create that percentage. She's investing it monthly. So usually if we're doing it monthly, we would say, oh, we're going to take that percentage and we're going to give that out 12 times monthly. Okay, but here's where they get us. Which expression represents the value of her investment after T years? Years. So we don't want this. We don't want to give it. We want to give it in 1 year. So I'm not going to split this into 12 months. I'm going to leave that as years. Okay? So this is a yearly rate. So therefore, this has to be a yearly rate. So if this is monthly, there's 12 months in a year. Okay, I have to include that value. So your answer is going to be choice 1. Choice 1. Okay, taking a look at number 5, consider the end behavior. Oh gosh, we've seen this. So as x approaches negative infinity, that means as I look down the x-axis, as I look over here, the graph is going to go to positive infinity. It's going up. All right, so basically, if I was to sketch this myself, as I look down here, the graph better be moving up. Okay, well, 2 of these are equations. 2 of these are ready to go. Uh-oh. This one's not pointing up. Uh-oh, that one's not pointing up. Darn it. So I need to actually go and I need to take a peek at these. You know what? I'm not even going to. This is a 4th degree polynomial. The leading coefficient is positive. 4th degree, it's going to be U-shaped. So it's going to be something like that. Okay, this is not perfect at all, but this gives you an idea. All right, this one is a cubic. So it's going to be a wormy with a negative leading coefficient. So I know it's going to be going down, down, worm, down. Okay, now I could graph both of these in my calculator, but I know that this is about what they look like. Both of those graphs are pointing up on the left side of the x-axis. So let's take a look at the second clue. As x approaches infinity, the graph is going down. Okay, so that means as I am looking up the x-axis over here, the graph has to be pointing down. Well, out of the 2 that are left, this one is pointing up in the right direction, and it's pointing down in the right direction. There's your answer. Boom. Okay, you could absolutely graph those and take a look. All right, but I don't have to because I know my rules with exponents. And last but not least, the expression is equivalent to. Okay, you can get around this one. You can put a number in for x and you can put a number in for a. Type this in your calculator. You're going to get a nasty decimal, and we're looking for which one is equivalent. So you're going to type these in, and you're going to look which one gives you the same nasty decimal or number that you got here. But what I want you to know is that this is just a trinomial. Okay, this is almost the same thing as x squared plus 5x plus 4. Almost. Okay, so if you were going to factor a trinomial, we're going to go into our parentheses like that. Okay, and usually it's an x squared, so I'd write x and x. Well, here's the problem. It's not x squared, it's x plus a squared. So it would be x plus a times x plus a. Well, then I'd go to the back, right? I'd look for factors of 4 that add to be 5. Same thing, factors of 4 that add to be 5. That's going to be 4 and 1. Tell me about the signs. They're going to be the same. What are they going to be? Plus signs. Boom, boom. There it is. Answer is number 3. Okay, I'm going to get off here before my dogs annoy me anymore. There you go.